Chapter 1, Lesson 7, Pre-Calculus, and we're continuing to look at modeling with functions. And I want to look at functions from graphs, and really I'm not going to do any examples. We're just going to talk about some things that you need to be aware of. Most of the examples you want to walk through are in your book. So when we're talking about functions from graphs, I'd like you to look at page 152 in your textbook, and you'll notice there's a diagram there, both of a box or a piece of sheet metal. We're going to fold up a box. I will do an example, but I'd like you really to look at page 153, where you take a look at a parabola, and you take a satellite dish, which is the actual shape of a parabola, and we know that the parabola shape is y equals x squared. So we can begin with that formula, and then in order to make the parabola fit an application, we would need to stretch it or shrink it. And so what we would need is we would need some value of, k, like some constant, that we would multiply by the function in order to get it. And then when we have a situation like this, hopefully you know that all you need is an ordered pair. That all you need is an x value and a y value to substitute into the expression, which would then allow you to figure out k. Because if we solve this equation for k, k would be equal to the y value divided by the x value squared. And so if we know the equation of the formula and we know a point on the graph, we can determine some of these values. So that's what it's talking about. So placing the diagram in a coordinate plane, placing it in a nice place, usually where there's a specific point at the vertex, then sets us up to be able to find some ordered pairs that we can then substitute into function equations as we're already aware of, and then determine the equation for that specific thing. So you would determine the points and then substitute them into the equation, and then apply the equation to the problem. Page 153 actually is what that one talks about. I will do the example from page 152 in a little bit after I cover some of these things, but just be aware, applicational is really taking things that we see in real life, putting them on the coordinate grid, and then doing with those pictures or those cross sections of real life items what we would do with just a graph that we placed or which we drew in there. We're really not doing anything different once we have those graphs or those pictures placed in the coordinate grid. Functions from verbal descriptions. Sometimes in page 154 example, they won't give you a diagram or they won't give you a cross section. They'll just describe what's happening. So you'll need to draw a picture for yourself, and drawing a diagram is a very important skill to be able to do. So you're going to need to read the problem carefully. Take a moment to think about what the words are saying. A lot of times students read it, they say the words, but they're not really thinking about what they're saying and not taking the time to understand what the words say. And that's really, I think, one of the major struggles with students in word problems, is that we tend to think that if we say the words out loud, we're actually reading, and that's only part of reading, being able to pronunciate or to know what the words say, but then to understand what they mean really requires that we slow down and that we actually think about the words that we're saying, not just saying them out loud. We need to ask ourselves, well, what's being asked? What am I trying to figure out? What value are they looking for? Are there any formulas that apply to the problem that I'm looking at? What formulas do I know? What formulas maybe do I kind of remember? I don't know what they are, but if I could look them up, I'd know what they were. You have to think about what would apply to the problem. If I have a formula now and I need to know a value to go into the formula, is there a way that I can determine what that value is? So we have to ask ourselves these questions in order to get better at solving word problems. And this is very important too. A lot of things that a lot of times students don't take the time to do, and that is to develop a plan about what you're going to do before you start doing the math. It's very, very common. Most students, as soon as they come to a problem and they're looking at a word problem, the first thing they do, they just look for the different numbers in the problem, and then and then they just start multiplying them or dividing them and just not really thinking about what to do or what they want to do. They just, here's some numbers, let me just start throwing stuff around and seeing what happens, rather than taking a moment to think about how to get to the answer that I want to get to, and then start picking up the pieces that I need in order to do it. So really, taking the time to develop a plan is a skill that really needs to be practiced. And then functions from data we've talked about, these would be scatter plots. You look on page 155, you make a scatter plot, and then once you have the scatter plot, you think about, okay, which of the basic functions would seem to fit the data that I'm looking at, and then we would use the regression to do that. On page 157. So those are some different types of things that you're going to need to be able to do, and different types of problems in the textbook. I want to take the time just to do one problem here for you. It's a problem, very common problem that gets a lot of attention in math books and on standardized testing. Maximum value problems. In other words, what's the maximum amount of volume I could get out of this, or what's the maximum profit, or what's the maximum, cost. So in order to do these, we needed to define, and specifically we're looking at volume here, define the dimensions in terms of one variable. In other words, whenever we're solving an equation, we can only have one variable. So everything that we're going to look at, every length that we're going to determine has to use the same variable. So we're going to need to know what the relationships are in order to use that one variable. Once we know that, we can just substitute these dimensions into an equation. Length times width times height, or length times width, or pi r squared, whatever it may be. Once we have it, we can substitute in. And then we want to use our graphing calculator to solve. When we're applying a problem to real-world situations, I don't want you to take the time trying to do the calculations by hand, because in many times those calculations are not going to come out even. They're not going to be nice, easy problems to work with, because in real life things are really, very rarely come out nice and even. So the time to practice solving them by hand was done earlier in the exercises when you were doing the problems that they gave you. When you come to a real-world applicational problem, then once you have your equation set up, then go and use the calculator. It's the quickest and easiest way to do it, and that would be the time when it would be wonderfully great to use a calculator. So let's take this. So we have a square or rectangle. No, I'm sorry. A square with sides x in length is going to be cut from the corners of an 8 by 15 inch piece of cardboard, and then the sides are going to be folded up to form a topped box. So again, so you have this rectangular piece of cardboard, this square right up here in the corner. These dimensions are all going to be the same. We're going to cut those out, which will allow us then to fold up the sides. And again, this is a very typical type of problem that you would find in a test or standardized test. So the first thing is we want to write the volume of the box as a function of x. So we have to remember the volume formula, and the volume formula for any rectangular or cubic type of figure is length times width times height. So we need to know the length, we need to know the width, and we need to know the height of our box using x as our variable. So the first thing we want to do is to label our diagram. So we know that it's 8 by 15, and so we label 8 by 15, and we know that the dimensions of these little squares are going to be x. It says we're going to cut out a square with sides x. So I know this is x and this is x. So I label the diagram that gives me those dimensions. So once we have this labeled in, now I need to determine what's going to be the length of my box. Now my box, I'm cutting these corners out, so my box that I'm actually going to fold up, the length of it is only going to be from here to here. That's going to be my length, okay, of my box after I cut out these squares. So what is that length going to be? It's not going to be 8, because that's the length of this, but I am going to cut out x on this side, and I am going to cut out x on this side. So the length of that box is actually going to be, or let's call it the width, is actually going to be 8, the length of my original piece, minus 2x, because I'm going to cut out x here, and I'm going to cut out x here from the width. Now the length, I'm going to do the same thing. It's originally 15, but I'm going to cut out x here, and I'm going to cut out x this way, so my length is actually going to be 15 minus 2x. Then when I fold up the sides of the box, this is actually going to be the height of the box. So my height is going to be x. So now that I know the length, the width, and the height, I can write my equation. The volume is going to be the length, or let's take the height, we'll just put it in order, times the length times the height, or width, excuse me. We then want to look at the, we're going to skip this middle step. The domain, well, let's just talk about it. The domain, remember, we're talking about volume. And if we're talking about L times width times height and we graph it, we're actually going to have negative values. But we're talking about the actual volume of something. So we're really only going to be looking at x values that are greater than 0, because we're not going to cut out a negative length. We can't. So the domain, when we come to calculating, we're only going to look at values that are larger than 0. Now, to determine the volume, the maximum rather, we just graph the equation that we have and look for a maximum. So if we put this equation into our calculators and graph it, this is the graph that we get. And you'll notice that it reaches its maximum point right here. So in order to calculate what the maximum volume is, remember, what means the y value, what is the volume, where would be, how much of the size x we're going to cut out. So we would then use our calculator to calculate this maximum. We're going to get an ordered pair, and we're going to be interested in the y value because that's the volume that's represented. All of these points along here are different volumes with different lengths of x being cut out. So when I do that, I figure out or I determine that the volume is 90.74. Okay, so that is answering the maximum volume. How much should we cut out? In other words, what should be the length of this? Well, that's x. So we go back to our graph and we calculated this already, 90.4 or whatever it was. Now we want the x value because that's how much we're going to need to cut out. And if we look at that, the x value is 1.67. So I need to cut out 1.67 inches this way and 1.67 inches this way. And if I do that, that's going to give me the maximum volume of 94 or 90.47, whatever it was. So then the side of the box is going to be, the height is going to be 1.67. The length is going to be 15 minus 2 times that 1.67. And the width is going to be 8 minus 2 times that 1.67 if I wanted the dimensions of the box. Okay, so those are some tips and some things you need to read through your book to kind of get a handle on some of the things that you're going to need to be doing. And again, practicing solving word problems and practicing applying is going to be a major emphasis of our course this year. So we want to begin right now developing some good habits in attacking these problems. And again, some of those habits are developing a plan before we start, looking at formulas, placing the figure in a coordinate grid and looking at some points that you could then use to determine equations, and then using our calculator to calculate the answer. So begin working with those, and we'll move on from there as we go through the rest of the year.